Guys, we're looking at lesson 94 today, and we're talking about uniform motion problems of the form D1 plus D2 equals N. Now, in previous uniform motion problems, what we've dealt with are, distances that are equivalent to each other, right? So we've said, well, maybe we have a starting point, we go some distance, and then we return, right? Where D1 and D2 are equivalent. Or maybe we go one direction, and then we have another thing moving that same direction, same speed, or maybe not same speed, but same distance, right? So those distances were equivalent. Now we are going to be dealing with problems that state the sum of two distances equals some number, right? If I take the distance of my first item and add it to the distance of my second, I'm going to get some number. Okay, so let's look at our first problem. This is practice problem A. An eastbound bus left Ukiah at noon. 2 hours later, a westbound bus left the same station. If the buses traveled at the same rate and were 500 kilometers apart at 6 p.m., let's find the rate of each bus. Now, what we know is that the rates are equivalent. So the first thing I'm going to say is, well, rate and rate. These things are exactly the same. I'm going to throw in the same variable for both of those. Okay, so let's draw a picture of what's going on. Okay, so we've got an eastbound bus that left at noon, right? So at 12 o'clock noon, we have a bus heading east. All right, that's heading east. And this, we'll write a little B1 for bus 1. Now, 2 hours later, we've got a westbound bus. So 2 hours later, that's going to be at 2 o'clock. We've got a westbound bus. What we know is the buses traveled at the same rate, and the total distance between the two of them is 500 kilometers. And they are 500 kilometers apart at 6 p.m., right? It's important for us to kind of try and think about this and label it appropriately, so that we can fill in all the little pieces that we need. Okay, so how long was bus 1 traveling? Well, if it started at noon and it ended at 6 p.m., we can say, well, that's just 6 hours, right? I can plug in an actual number for time. What about bus 2? Well, it left 2 hours later than bus 1, right? 2 hours later than bus 1. So at 2 o'clock, 2 to 6, well, that's just 4 hours. So what's the distance of bus 1? Well, we don't know the exact distance, but what we do know is that rate times time is distance. So we get to say 6 times the rate is the distance that bus 1 went. We get to say 4 times the rate is the distance that bus 2 went. Well, how are we supposed to utilize this? Well, we look at it and say, the two distances added together have to equal some number, right? That's this whole concept right here. The two distances added together equal some number. And it just so happens that we know the number that they're supposed to add up to, 500 kilometers. We've been told that the total distance between these two buses is 500 kilometers. So we get to say 6R plus 4R, the distance of my first bus, plus the distance of my second bus is equal to 500 kilometers. With this setup, we get to solve for R. We divide both sides by 10 after combining like terms, and we get the rate of both buses is 50 kilometers per hour. Thing of beauty, guys. It's beautiful. All right, let's look at our next problem. And always, if you want to, go back, pause this, do whatever you want, work through it on your own. Again, go for it. You can rewind this, pause it, and do it on your own. Let's look at practice B from problem set 94. It's on page 393 for those of you who can't read my handwriting. A train starts from Peoria at 2 p.m. and heads for Reedley. So you know what I'm gonna draw me a little picture. I've got my train. It's at 2 p.m. and it's at Peoria, and it is heading towards Reedley. And I'm actually gonna do it like this, and it's heading towards Reedley. Let's put Reedley over here. We know that the distance between these two is 750 kilometers, right? Train starts from Peoria at 2 p.m. and heads for Reedley, which is 750 kilometers away. At the same time, so that means also at 2 p.m., a train leaves from Reedley and heads for Peoria. And it's moving at 85 kilometers per hour. If the trains meet at 5 p.m., what is the rate of the first train? So we're looking for the rate of the first train. Look, we already know the rate of the second train. And so we need to solve for this guy right here. We need to figure out what that rate is. Well, how long have they, excuse me, how long have they been going, these two trains? Well, I can go from 2 p.m. to 5 p.m., 2 p.m. to 5 p.m. Oh, well, they've both been traveling for 3 hours? That's lovely. Oh, man. Oh, man, look at this. How far has train 2 been traveling, guys? Well, to answer that, all we need to know is that rate times time is equal to distance, right? That's 85 times 3, which is just 255. We know the distance. We know everything about train 2. We know how fast it was going, how long it traveled, so therefore we know the distance it traveled. That's just fantastic. Look at this. 255 kilometers. It was traveling for 3 hours. It was moving at 85 kilometers per hour. Oh, just a thing of beauty. Well, what was the distance of train 1? We don't know because we don't know the rate, but we can at least write out an expression using rate times time is equal to distance. We can write out an expression to show how far train 1 went. Okay, so well, how can we utilize this to solve for R, right? How can I utilize this to solve for the rate? Because that's what I'm looking for. What is the rate of the first train? Well, what I need to do is I need to use this total distance that was given to me early on. I need to use this total distance that was given to me early on. What I know is that the distance of the first train plus the distance of the second train is equal to 750 kilometers. We know that Peoria and Reedley are 750 kilometers apart. We know that first train was moving east, well, maybe. We know that the second train was heading west, maybe, but we know that they meet somewhere in the middle. So their total distances have to be 750 kilometers. So what I get to do is I get to say, well, 3R plus 255 is equal to 750, right? Distance of my first train, distance of my second train, total distance. So let's subtract 255 from both sides. Cancel from the left. We get 3R is equal to, well, let's see, 750 minus 255. I think it's 495. We get to divide both sides by 3. And 495 divided by 3 is just 165. So that right there tells us the rate of the first train was 165 kilometers per hour.